Hello, and my name is Muhammad Akbar, and today I'm excited to present my project Spectral Siege, a custom-built game created using my own game engine, developed with SFML, simple and fast multimedia library, and C++. This presentation will go over the development process, technical aspects, and key challenges encountered while building the game. So I'll move on to the introduction and overview. Spectral Siege is a fixed position arcade shooter where the player defends a central base against a wave of spectral enemies. The game was built entirely from scratch using my own game engine. The project's main focus was on creating a scalable, high-performance game engine capable of handling dynamic enemy AI, collision detection, and an adaptive difficulty. And an adaptive difficulty system that keeps players engaged. Throughout the development process, I worked on refining these core mechanics, optimizing performance, and ensuring smooth gameplay. So for my project objectives for Spectral Siege, I needed to create a custom game engine using SFML, focusing on modularity and reusability. I also had to implement dynamic enemy AI, or the ghost in the game, that adapts based on the player's performance. I had to optimize collision detection when rendering to maintain smooth performance, and to develop a leveling system that increases difficulty over time by adjusting enemy spawn rates and speed. Also to ensure smooth responsive controls and well-balanced challenge for players. Each of these objectives was tackled throughout different stages of development, and I'll not take you to the process I made so far. So at the start of this project, my initial plan was to build a game engine that could support an endless shooter with intelligent enemy waves. The goal was to structure it in a way that could be extended for future games. So far, I have successfully implemented player movement and shooting mechanics, enemy AI with dynamic spawning, bullet and enemy collision detection, a level progression system that increases difficulty based on kills, a scoring system to track player performance. Like with any game development project, this one had its challenges. Initially, I encountered issues with balancing difficulty progression. The game became either too easy or too overwhelming, so I revised the level up system to be based on kills rather than score. I also found issues with optimizing collision detection. I refined the hitbox calculations to improve efficiency when handling multiple objects on screen. Lastly was the rendering performance. The number of enemies that increased. I ensured that the number of enemies increased. I ensured that as the number of enemies increased, the game maintained a smooth frame rate. So despite these challenges, I was able to adapt and refine the mechanics to create a more engaging and scalable experience. Now onto my key stakeholders. So every project involves stakeholders who play an essential role in its development and refinement. Stakeholders are individuals or groups who have an interest in the project, influence in its direction, or are directly impacted by its outcome. So for Spectral Siege, I myself am a stakeholder because I am the sole developer of this project. I have full control over the design, the mechanics, the architecture, and the programming. And my responsibilities include coding, the core game engine, optimizing performance, and ensuring all gameplay mechanics function correctly. And the decision making also relies on me. The debugging, managing the development timeline, all of it is my responsibility. And my second stakeholder is my supervisor, who is named Legion. She acts as an advisor, providing technical expertise and constructive feedback. I have regular meetings with her, and she has discussed with me about the game mechanics to optimize the code efficiency and to ensure that the project met the academic and industry standards. So the discussions I've had with her also influenced my key decisions, such as difficulty balancing and architecture modifications. Then I have my family, peers, and testers. So they've all provided or gave essential feedback on gameplay experience, difficulty progression, and overall enjoyment of the prototype I have of the game so far. So through peer play testing, I gathered insights into user experience issues such as movement, smoothness, enemy behavior, and responsibilities and responsiveness of controls. Playtesters helped me adjust leveling mechanics, the AI difficulty scaling, ensuring the game remained both engaging and fair. And lastly, is a stakeholder that will come later, but they are the future players. And the final group of stakeholders consists of future players who will experience the finished game. And their potential feedback on game mechanics balance and entertainment value will influence future updates and expansions. A well-developed project can open doors to a broader audience, leading to continued improvements and community-driven enhancements. These stakeholders directly impacted my development approach, helping refine the game mechanics, performance optimizations, and overall user experience of Spectral Siege. Up next is the project requirements. Clearly defining functional and non-functional requirements was essential in structuring the development process and ensuring a smooth workflow. So the functional requirements, as mentioned here, are the player movement controls, so that the player can rotate and shoot smoothly using keyboard inputs. Shooting and bullet mechanics, bullets spawn correctly from the player and interact with enemies. The AI system, enemies spawn dramatically and move toward the base. Collision detection, proper detection between bullets and enemies, as well as player-enemy interactions. Leveling and progression, enemies increase in number and difficulty as the player progresses. Scoring system, players earn points but for shooting enemies and additional points for enemy collisions. And for non-functional requirements, these requirements ensure performance, efficiency, stability, and extendability of the game. So the ones I've implemented are performance optimization, so smooth frame rates with multiple entities on screen. Modular code structure, designed for easy future modifications and updates towards the engine and the game. And responsive controls, which is important for player input with no noticeable lag. So by maintaining a clear requirement structure, I was able to prioritize development goals while leaving room for future enhancements. And next is the system architecture overview. To better understand how Spectral Siege's engine operates, let's take a look at the system architecture. So the diagram on the right represents how different components of the game engine interact with one another. At the top we have the game loop, which is where it starts. This is the core of the game, and it continuously runs while the game is active. It ensures that every frame 3 key operations occur. Number 1, the processing input. This captures players' actions, such as rotating the character or shooting bullets. Number 2, updating the game state. This step updates all game objects, including enemy movements, bullet physics, and collision detection. And third is rendering everything to the screen. The final step draws all the objects to the screen, ensuring the player sees a smooth and visually updated game. So the input handling module captures player input from the keyboard. If a movement key is pressed, it updates the player's rotation. If the shot button is pressed, a bullet is spawned at the correct position. And then the game logic module is responsible for managing gameplay mechanics. It ensures enemies are spawned at appropriate intervals, bullets traveled in the right direction, and the player's score is updated when the enemies are destroyed. Up next is the physics and collision detection module, which plays a critical role in detecting interactions between bullets and enemies. When a collision is detected, the enemy is removed from the screen, and the player is rewarded with points. Finally, the rendering module handles all the graphical elements. It ensures that every frame of all the game objects are drawn in their correct positions, making the game feel smooth and responsive. So this modular design allows for better performance, easier debugging, and future scalability. If I want to expand the game with new enemy types or power-ups, these systems can be modified without affecting the entire game structure. Next is a small mention of the level progression system. So a major part of Spectral Siege is leveling up, which dramatically increases difficulty. So here's how it works. So every 10 kills is a level up, and at levels 5, 10, and or 15 and so on, the required kills increase by 10. Enemy spawn rates increase slightly with each level, as well as they move slightly faster. The system ensures the player is challenged by more enemy numbers rather than overwhelming speed, making the game engaging but fair. So now I am going to be talking about the challenges that I've faced and how I found the solution for them. So the first challenge I had to face was the bullet spawn position. So this issue, initially bullets spawned at the player's center instead of in front of them, making aiming feel inaccurate. So for this fixed, as seen by the code here, by calculating the spawn position using trigonometry bullets, trigonometry bullets now appear slightly ahead of the player based on their rotation. So as seen through the angle, it converts the angle to radians, which is for correct calculations, and then the player get position as well as the vector all help to put the offsets of the bullets in front of the player. And then the last bit of code here will spawn a bullet will spawn a bullet in front of the player instead of their center. So now bullets spawn directly in front of the player, ensuring better accuracy and a smoother shooting experience. The other issue I faced was checking every bullet against every enemy caused performance issues at high enemy counts. So how I fixed it was using iterators and breaking out of loops once a collision is detected, which reduces unnecessary computations. So as seen over here, so yes, enemy hit, enemies erase. So this removes an enemy when hit by a bullet, and then bullet, and the same one is for the bullet, which is bullet hit, bullets erase. This removes a bullet on collision, so after a successful hit towards the ghost. And then you also have break, which helps to stop checking further once the bullet hits an enemy, improving efficiency and saving up on performance. So by removing elements effectively, the game maintains a smooth frame rate even as enemy count increases. The last challenge I faced was the difficulty balancing. So the issue was that enemies scaled too quickly, making later levels overwhelming. And how I fixed this was that I introduced a system where every 5th level increases the required kills to level up, slowing the difficulty curve. So as seen through the code over here, this makes sure that the difficulty increases gradually rather than suddenly, and then the enemy spawn time also reduces so that at a slower rate to maintain balance, and gradually reduce enemy spawn time. And then enemy speed multiplier ensures enemies become slightly faster over time without becoming overwhelming. So now the game increases difficulty at a steady pace, ensuring fair but challenging progression. So now I'm talking about my schedule, which I've been following along really well. I've started with game engine research and then moved on to basic player controls, the shooting system, enemy AI, collision system, level progression system. All these have been followed through the weeks that I have set them up, and I've been following them, completing them really well. All that's left now is just the refinements for the game and playtesting it, and then having the final adjustments in the last week, so that the game is fully completed and everything that I have set out to do is all completed at once. So now this is my conclusion and my future work. So to summarize, the game engine is fully functional and scalable. The core mechanics are implemented successfully. The leveling system provides a dynamic difficulty. So future improvements that I will focus on are adding sound effects and background music, and introducing new enemy types and behaviors, and expanding UI elements for better player feedback. This project has been an exciting challenge, and I look forward to further enhancing it. That is it for my presentation. Thank you for your time. I appreciate the opportunity to present Spectral Siege and look forward to your feedback. Thank you for watching.